Industrial transformation is underway, and the domains of manufacturing and supply chain engineering, execution, and optimization are at the center of this transformation. Let's take a look at how one company envisions the future of assembly and supply operations.
Let's take a look at the plant of the future. The workspace is our open plan, heavy physical tasks performed by robots, and quality controls carried out automatically and approved by the operators. In the body and white workshop, a comprehensive check of the geometry of parts is done using laser pointing. In the paint shop, the printing system integrates customized solutions into the production process. In kitting areas, operators and robots make up the assembly kit based on the customer's order. This process, known as full kitting, has been rolled out across our workshops to guarantee flexibility. The kit is then matched up with the vehicle on the production line. To ensure assembly goes smoothly, the main production line handles operations common to all vehicles, and specifications on diversity are handled through parts collected in sub-assemblies prepared on feeder lines. Augmented reality programs allow continual training for the operators, increasing their versatility. On the production line, real-time interaction between the plant and the design team facilitates the production of new models. None of our robots, either at the body and white or assembly stage, are fixed to the ground, so we can move them around freely. The plant of the future is about combining technology and human skills to optimize flexibility.
As shown in the PSA Group video, the factory of the future requires operational agility and flexibility while seamlessly integrating 3D and virtual technologies in the physical manufacturing environment. The 3D Experience Platform is the digital continuity foundation that supports the four key domains of process engineering, manufacturing engineering, value network engineering, and operations management, which will drive the factory of the future. Let's briefly explore each of these domains. The process engineering applications within the 3D Experience Platform enable virtual modeling and simulation of your manufacturing lines, cells, and resources, while establishing the digital twin framework required for the factory of the future. This includes virtual definition of the plant layout, factory flow and throughput validation of your production lines, offline programming and simulation of your robotics and equipment and human ergonomics validation, and this digital 3D environment can then be used to support virtual training of your manufacturing associates. Essentially, the entire factory and its resources can be defined and validated in a virtual 3D world, accelerating time to market, reducing launch times, and achieving first-time right objectives. Let's look at the process engineering domain capabilities a little more closely. Here you can see that a virtual twin of the production line has already been defined in the 3D Experience Platform. This can be modeled in 3D Experience DELMIA or can be imported from a 3D scan as a point cloud. In this simulation, a new subassembly entry point is being added to the main line for the new E-motor. Existing 3D line and resource definitions can be quickly modified to support new product introductions or production changes as product demands change. Once a production line is defined on the 3D Experience Platform, all of the physical interaction can be simulated to ensure compliance with the original design. Here you can see the seat installation path validation for the blue car to identify any clashes between product or factory equipment and eliminate launch issues. Introduction of automation like robotic seat installation can also be done leveraging the existing virtual factory model and can be used to perform what-if analysis. Ergonomics play a critical role in the factory of the future as determining human capability, protecting workers, and ensuring maximum productivity without injury and fatigue is a critical component of an agile and flexible operation. Here, as the operator is fastening the E-motor to the assembly, The simulation ensures that the operator and tool can access the fixture points and analyzes ergonomic quality. Is the mannequin in balance? Does he/she have the proper posture? And will the position and reach generate fatigue or cause injury? Offline programming and simulation of machining operations can also be done, supporting both additive and subtractive machining operations in the virtual environment. Virtual training is a critical concern in the factory of the future, as the impact of introducing new operators or new processes on the line requires minimal disruption in terms of both performance and quality. In most cases, 3D work instruction definition would be enough for assembly operators. But in this example, the operation was more complex as it involved use of a specific torque tool. Based on the 3D model of the corresponding station, equipment, and product, a virtual training scenario was created, allowing the operators to become familiar with the operation prior to starting production. As a 3-minute takt time was the goal, validation of the operator's ability to complete the process in time was also confirmed. Now, let's briefly look at the manufacturing engineering domain. This capability domain of DELMIA and the 3D Experience platform addresses the transition from your validated manufacturing simulations in virtual space to the physical execution of your operations within your plant. This includes maintaining the manufacturing bill of material integrity based on product definitions and changes generated by product engineering, defining the manufacturing process plan and all of the detailed attributes of timing and resource requirements for each step, and creating the associated 3D work instructions that will be presented to the operator on the shop floor in the operations domain. Managed by the 3D Experience platform, these capabilities provide the foundation for agile and flexible manufacturing in the factory of the future, providing both validation and control of manufacturing process integrity in a virtual world before execution in a physical world. Let's look at the manufacturing engineering domain capabilities a little more closely. Maintaining fidelity between the engineering bill of material and the manufacturing bill of material is critical to the factory of the future, as engineering changes occur frequently. In this example, engineering has identified a replacement engine bracket to support the new E-motor. This change is now being propagated from E-BOM to the M-BOM, ensuring that all variant and configuration relationships remain synchronized and aligned. This change will also be applied to the virtual manufacturing process, as this defines the sequence of assembly operations. Changes are easily identified through color coding within the BOM tree structure. The progressive buildup of the product is presented and assembly simulation is validated to ensure that data and process integrity are maintained. Once the process plan is defined, it can be used to generate the 3D work instructions. Here, another component within the blue car is being assembled. The 3D image, the on-screen text, and all views come directly from the 3D Experience platform. The view here is the actual operator screen, which contains multiple 3D views with animation for each process step. Now let's briefly look at the value network engineering domain. The value network engineering domain offers a broad set of powerful solutions to address sales and operation planning for the enterprise and logistics planning for both the external supply network as well as internal logistics movement, including AGV optimization. The 3D Experience platform value network engineering domain takes the modeling and simulation information generated in the prior two domains and matches them with the reality of customer demand and supply chain limitations to create an achievable plan for the entire value network. This includes analysis and optimization of sales and operations plans, external logistics with suppliers, customers, and plants in your enterprise network, and internal logistics using automated guided vehicles or AGVs, cranes, forklifts, and other material handling resources. The entire value network can be planned and optimized for maximum customer service and profit margins and minimum costs and waste. Following is a more detailed look at 3D Experience Value Network engineering capabilities. The 3D Experience Platform Sales and Operations Planning module matches customer demand and forecasts with the capabilities and limitations of the value network based on the models created in process engineering and manufacturing engineering to analyze and optimize the capabilities of your value network. It enables the creation of multiple capacity, sales level, and supply level scenarios that take into account all material flows and bottlenecks. It then provides what-if analysis of these scenarios to generate a sales and operations plan that maximizes customer service and profit margins and minimizes cost and waste within the value network. Logistics optimization looks at material movement outside the plants, from suppliers to plants, from plants to plant in your network, and from plants to customers. It analyzes possible shipment legs, potential transport methods such as truck, rail, air, etc., and available routes, and looks at their effect on key measures such as late shipments, total distance traveled, total routes used, and total transportation costs. Users can review select shipment legs and routes that are critical to the business and make manual adjustments if desired. The system can then automatically optimize the entire logistics plan, taking into account all requirements and constraints to minimize costs and reduce or eliminate late shipments. Logistics inside the plant are just as critical as logistics outside the plant. 3D Experience Platform AGV and Plant Traffic Optimization helps plan and optimize all internal plant logistics. Plant traffic optimization takes into account production schedules, available materials, plant layout, and all available internal logistics resources such as AGVs, forklifts, and so on. Using this information, the user can manually assign required material transport orders to specific resources, and the system will ensure the appropriate resources are used and available for the assigned activities, with visual warnings of exceptions. Plant traffic optimization can also automatically calculate an internal logistics plan that maximizes delivery performance, minimizes lateness and wait time, and avoids collisions between resources such as AGVs and forklift trucks. It can also take into account required maintenance such as charging time for AGVs to ensure that the right resources are available for all required activities. We'll now take a look at the operation management domain. The 3D Experience Platform Operations Management domain turns the modeling and planning domains into reality on the shop floor. Operations Management refines the sales and operations plan into an executable plant schedule, pulls together the process engineering and manufacturing engineering information into an executable production process, which it then enforces on the shop floor, provides IIoT capabilities with multiple types of shop floor equipment, supports multiple real-time manufacturing analytics, and ties all of this together with lean management methodology. Let's take a closer look at the manufacturing operations management domain capabilities. The reality on the shop floor is that things change every day. Customer orders change, items are scrapped, machines go down, and so forth. The 3D Experience Production Plan Scheduling module supports the factory of the future by integrating all other applicable digital continuity elements such as product designs, process plans, and so forth with the current reality on the shop floor to bring integrated planning and scheduling into your plants. It covers three key processes: plant master scheduling, plant detailed scheduling, and line balancing, and streamlines your planning and scheduling processes by modeling all of your manufacturing constraints at finite capacity with automated optimization engines built in. It identifies bottleneck issues, and it supports what-if production scenarios with unlimited simulations in order to reach your planning objectives. The 3D Experience Lean Management Solution is designed to digitize the daily production meeting, often called the 5-minute meeting, monitor the performance of production cells, document and track daily tasks assigned at the daily meeting, and enable collaborative problem solving. It takes advantage of touchscreen technology combined with 3D Experience platform to improve and automate many lean management tasks. Employees can be checked in and assigned to work cells. KPIs can be displayed and automatically updated from other systems or manually updated by responsible employees. Issues on the floor can be identified and documented, and these issues can be assigned and tracked to completion. 3D Experience Lean Management provides many advantages over manual lean processes, including digital entry and maintenance, which is interactive and easily organized, simpler and faster preparation of meeting content, and information pulled from members is visible from anywhere and all data is tracked and archived. The 3D Experience Manufacturing Operations Solution is the bottom line reality for the factory of the future. It pulls together all of the process engineering, manufacturing engineering, and value network engineering information and pushes required information to operators and machines on the shop floor. 3D Experience Manufacturing Operations provides directed shop floor execution based on process and manufacturing engineering as well as the detailed production schedule. It integrates quality processes to ensure all quality checks are performed and results are within acceptable ranges, and provides directed issue correction and rework if quality issues do occur. 3D Experience Manufacturing Operations provides real-time material synchronization throughout the factory based on the MBOM, process plan, production plan, and real-time shop floor events to ensure materials are available at the right place at the right time. This includes providing materials, subassemblies, and kits in sequence to sequenced assembly lines. It provides integrated maintenance operations to ensure maximum machine availability and integrates tightly with shop floor equipment. These broad capabilities work together to help improve quality, improve productivity, reduce inventory, and reduce waste, helping ensure maximum production performance while reducing manufacturing costs. Two key elements of the factory of the future are Industrial Internet of Things, or IIoT, and manufacturing analytics. 3D Experience Platform IIoT Manufacturing Analytics provides these elements as part of a complete Factory of the Future platform. 3D Experience IIoT Manufacturing Analytics provides real-time integration to multiple types of shop floor and field equipment. One key to this capability is the ability to provide two-way communication to both collect machine execution results and drive machine execution. You can push data to shop floor equipment such as machine programs and variables, machine actions based on products being produced or data from shop floor activities, and other key information. You can view real-time machine variables and status as well as historical machine performance information from anywhere via the web-based user interface, and details of status, downtime history, and other critical machine information can be available with one click. Data historian information for high-volume data visibility and tracking is also available. Analytics for all of this machine information, as well as other production, quality, employee, and maintenance information is available through both out-of-the-box and user-defined analytics, providing you with unsurpassed visibility into your shop floor operations. The digital continuity capabilities provided by the 3D Experience platform provide the key capabilities needed to support the factory of the future on a single, unified platform. The factory of the future uniquely ties together the virtual world and the real world, extending and improving real-world operations. It improves the details and capabilities of the virtual world by providing feedback from real operational experiences. It enables the capture and sharing of knowledge and know-how, and it provides ongoing collaboration in all areas with broad information capabilities to provide decision support. The factory of the future is uniquely supported and enabled by the 3D Experience platform.